Hello, welcome back to Learning with Ms. H. We are in Earth Science, and today we're going to do our weathering lesson. So let's take a look. You're going to go into the modules page and onto the weathering lesson page. And in here, you have a starter or bellwork assignment. You're going to write down a summary of what you already know about rock breaking down, how that happens, and how they change from one form to another. So jot some of that down in your notebooks, just to kind of jog your memory on how they change and see what you already know about how they break down. So go ahead and pause me, grab any of your supplies that you haven't already. Once you've grabbed your supplies, go ahead and do this starter assignment, your bell work, in your notebooks. And then once you finish that, go ahead and come back and join me for the lesson. All right, welcome back. For today's lesson, we're going to go through weathering. So we're going to take notes on weathering, and then you have an assignment down here. I'm going to go through the assignment first, so that those of you that don't want to watch the video for the notes can go ahead and stop it, take notes on your own, and then get started on the assignment when you're ready. So let's take a look here. I'm going to open this in a new tab. Your weathering homework assignment is actually a web quest. So you're going to go to this website here, and you are going to look for answers to all of these questions here. So define weathering, tell me the two types, and then list all of the examples of those two types of weathering. You can also find this in your notes. Part 2, we learned a little bit about the Grand Canyon, and you did a research assignment on it already. We're just going to review a little bit about how the Grand Canyon was made by watching this video. It's only a couple minutes long. And then you're going to link that back to our prior learning from the unit that we talked about tectonic plates, and see how they had a hand in creating the Grand Canyon or getting that process started. And then you're going to talk about some different features and things that happen with weathering and erosion. The final part here, you are going to be looking up these land masses or these land features, and then describing the feature, and then tell me what type of weathering is going on there and how that feature was formed. And there's a whole table of these. So you've got about 5 places here that you are going to look up, 6 actually, that you're going to look up and fill in this table. Once you're done, you will turn this in. It is for points. So make sure that you go ahead and get that turned in. And then when you're done with this, you are done for the day. All right, so if you're going to do notes on your own, you can go ahead and stop the video, take notes, and then work on your web quest. If you're going to join me for the notes, go ahead and get ready. We will go through those now. Okay, we are going to get into our weathering notes. So let's go ahead and get started. This image is from Monument Rocks. It is a location out in the plains in western Kansas. It's outside of a town called Oakley, Kansas. And Monument Rocks is a location where the whole area used to be covered by the shallow sea, the Western Interior Seaway. And there's a video that will be attached down at the bottom of the lesson as an additional video you can watch that connects weathering and erosion in this area with fossils, geologic time, Western Interior Seaway. This location has lots of marine fossils in the region. These are chalk columns that have been compressed. They were laid down when the area was covered by the shallow sea. They go down about 70 feet below the ground, and they are very tall above ground, as you can see. They have been weathered by wind, rain, all kinds of things happening here, and that's how it got the shape that it's in. It's called the Sphinx because it kind of actually does look like the silhouette of the Sphinx. You can kind of see some legs here and here, and the head and the body. So it does look a little bit like a Sphinx. That's why they call it that. The video will take you around the entire area here. There's actually 2 basically islands of these salt pillars in the region. There's Monument Rocks that has 2 formations at it, and then there's one called Castle Rocks that's about 20-30 minutes away from Monument Rocks. And it's called Castle Rocks because it actually used to look like a castle, and one of the spires actually fell over due to weathering about, probably 10 years ago now. But it's a really neat area. It's an area that you should absolutely visit if you are interested in geology, but that's where this picture came from. So let's get into our weathering notes. So what is weathering? Weathering is the breakdown of materials of Earth's crust into smaller pieces. So all of these rocks on the surface get broken down into really small particles. As always, when we're going through these notes, make sure that you give yourself plenty of time to finish the slides. You are always welcome to pause the video, finish what you need to, and then restart it to move on to the next one. So this is a time lapse of weathering happening. I'm going to skip through this on my lesson video, but what I'd like for you to do is pause my video right here, watch this one, and then come back to me. All right, so we have 2 types of weathering that we're going to talk about. We have physical weathering and we have chemical weathering. Physical weathering is also known as mechanical weathering, and it's the actual physical breakdown. So smashing something, chipping away at something. It breaks down the rock into chunks, but it keeps the rock with the same chemical composition. So it's still that same rock. It doesn't change what it's made of, it just changes the size and shape of it. Chemical weathering, on the other hand, is actually going to break the rock down chemically and change what it's made of. So it is no longer going to be the same rock. So we're going to take a look first at physical weathering. So we're going to break the rock down into smaller pieces using external conditions. Weathering and erosion are both going to be external conditions, but remember, this is leaving the rock the same rock, just changing the size and shape of it. So we're chipping away at it or breaking it apart. Types of physical weathering, we have frost heaving and frost wedging, friction and impact, plant roots, burrowing animals, and temperature changes. And we're going to take a look at each of these. So the first one we're going to look at is frost wedging and frost heaving. So with frost wedging, anytime you have water involved, water is kind of the opposite of all other liquids. When water freezes, it's going to expand. Most of the time when something solidifies, it contracts and it gets smaller. Water does the opposite because of its chemical makeup. So it's going to expand. So when you go from a liquid water to a solid ice, you're going to have a volume increase of about 9%. And so what that means is when you have a rock, so if you look at our image down here, this lower image, the boxes are going to represent rocks. When you have a rock with a crack in it, you get water in that crack. As that water freezes, it's going to expand and it's going to push out on that rock. It's going to push away. So it's going to get 9% larger and try to push its way out of there. As that happens, it's going to put pressure on the rock, and the more that it freezes, melts, freezes, melts, freezes, the more pressure gets put on the rock. Eventually that crack is going to get larger and larger until the rock breaks away. So you're going to have a piece of the rock just fall away. Over here on the right, you have an image of it actually happening on a real rock. This rock started off all one piece. We had a small crack here, water got into it, froze, expanded, and it actually, over time, chipped this whole piece of the rock away from the main body of it. The expansion of frost wedging can exert a pressure on an object that is hundreds of thousands of pounds per square inch, which is what causes that rock to fall away. So frost heaving is a little bit differently. You have water that seeps into the cracks and the pores of the rocks. The temperature is going to drop, the water expands, and it's going to wedge, just like it did before, but it's going to wedge these rocks apart. These are actually separate rocks here. They're not connected to each other, so they're going to shift and move as the frost, as that frost heaving happens. So as you get the water freezing and expanding, it's going to push them around and kind of get them out of place. The freezing and thawing is called frost action, and you can see in here these cobblestones are not very smooth anymore. You have some that are lifted up, some that are tilted, some look like they're sunk down. So this is not an even surface anymore because of all of that frost action happening. Frost heaving and frost wedging. The frost heaving mainly is one of the reasons that contractors always leave a gap whenever they do concrete slabs or wood decks, because you get the water in there, it can expand and contract. It's going to freeze and thaw. And as that water expands and contracts in between the concrete, if there's not enough of a gap, it can cause those concrete slabs to separate, to shift, to crack, those kinds of things. With the wood decks, it's a little bit different because the wood's actually going to absorb the water and swell and contract as it absorbs the water and then dries out. So the next type is friction or repeated impact, and this is called abrasion. Abrasion is going to happen whenever a rock is transported by some type of agent of erosion, so something that moves other things. So if you have water eroding away soil and rock chips, those soil and rock chips, even if you have large pebbles, anything that's moved by that water or ice or even wind is going to flow across or rub across wherever that water is going. So whatever it hits along the way, it's going to rub across it and cause an abrasion, which is just like skinning your knee if you fall, like getting one of those just minor skin abrasions where it just kind of scratches the surface of your skin. It's going to do the same thing when you have bits of items, so rocks, limbs, whatever, basically falling across something else, rolling across something else, flowing across something else. If it happens to hit it, it is going to dent or chip it or brush against it, rub against it, and it could rub off a bit of the surface there. So that would be an abrasion. So as these things bounce around, hit off of each other, they're going to break down. And it can be both of them that break down, the one doing the hitting and the one being hit, can both break down and chip away. So if you are looking at a stream, you should be able to tell, even if it's a calm stream, you should be able to tell what direction it's flowing just by looking at the rocks. Pause here and see if you can take a guess why. All right, did you figure it out? If you have things flowing downstream, smacking into things, rubbing against them, chipping away at them, you're going to have one side that is actually smooth and one side that is really angular. And so by looking at that, you can tell which is the upstream side and which is the downstream side. All right, plant roots. So when you have plants that are growing in an area that is very rocky or stony, the root systems are going to get into the rocks. They're going to go through the soil, they're going to grow down into the rocks. If there's a crack in the rock, that root can get into it. So if a root grows into a crack, the root's going to continue getting larger, it's going to continue growing, and as it gets bigger and bigger, it's going to push out against that crack. As it does that, it's going to push away, it's going to put pressure on that rock, and eventually it's going to allow more water into the cracks, and between the root pushing pressure on it towards the outside and the water freezing and thawing putting pressure towards the outside, it's going to cause those rocks to break apart again. Burrowing of animals is kind of the same concept. Some animals can actually burrow directly into the stone. Others may burrow underneath it and cause instability. So these are some images of some animals that are actually burrowing into the stone rocks. You can see some types of shipworms, mollusks, insects, all kinds of animals are going to actually burrow into the rocks. And as you can see, they hollow out the rocks here to make little homes for themselves. And the more they do that, the more stress they put on the rocks. So you see all these cracks coming off of it because you have this little hollow area that is no longer supported. So these guys that tunnel around or underneath the rocks are going to allow water and air to get into those rocky surfaces where it wouldn't normally, and then again allow the physical weathering to happen with the freezing and the thawing. Temperature changes is another way that you can get the physical weathering. There's a slow way and a fast way. Both of these images are going to be of the fast way. Let's talk about the slow way first. Rocks get heated up by the sun. As the surface temperatures warm, the rocks warm up. As it gets cooler at night, the sun goes down, temperatures go down, and as you get this cycle of hot, cold, that can actually lead to cracks in the rocks. The fast way to do that cycle is through things like snow, rain, something super cold happening, a cold snap in the winter, a forest fire. Those extremes in temperatures are going to cause that to happen much faster. So here is a video on how some companies actually use fire to break large boulders down. It's kind of a cool video to watch. It's a couple minutes long. So go ahead and pause this one. Take a look at this how to break stone with stone with fire video here, and then come back and join me again. All right, so let's move on to chemical weathering. Chemical weathering is the process that breaks rock down through chemical changes. What does that mean? It means it actually changes what the rock is made of. So instead of just breaking it down into smaller pieces or a different shape, it's actually going to turn it into something else. So things that can do this, you can have water, oxygen, carbon dioxide, living organisms can do it, and acid rain can do it. And we're going to take a look at these on the slides that are coming up. So the first one is water. When water gets into rocks, it's going to dissolve it. So over on the left here, we have a picture from the Giant's Causeway. You probably recognize this one from previous units. We are looking at basalt pillars coming up off the ocean floor. So we talked about that a little bit during our rocks unit. We can take a look at this and you can see the water pooling on these. And what's happened here is this is exposed surface. As the waves come up, the water pools on here because it's eroding away at the surface. The more water sits on here, the more it eats away at the surface of the stone. And the more pooling that you get, which means more water sits on it, which means it eats away at the stone more, which means you get more pooling, and it's a big cycle. So these water puddles you see here are what actually formed this image on the right. The image on the right is from a place called Elephant Rock State Park. It is in southeastern Missouri in the Mark Twain National Forest. And this is a spot that they refer to as a bird bath because when it rains, this is an indentation in the granite rock that's here, and this will actually fill up with water in this little region here. So that'll fill up with water. The water will dissolve away the minerals in the granite and make this deeper. So the first way, water dissolving rock. The second thing that can make it changes in it is oxygen. If you expose rocks to oxygen, some of them can actually have a reaction with the oxygen and change the chemical composition of the rock. Anytime you have that happen, you have oxidation occur, And one of the products of oxidation is rust. So if you look at this rock down here on the bottom, you can see a ring of rust forming around the outside of it here. So oxygen plus water is going to cause this rust-like chemical here. So we're actually changing the chemical composition of the rock. Carbon dioxide, this is a big one. We talked about the burning of fossil fuels. When we talked about geologic time, we talked about coal, oil, all of those deposits, how they came about. When we burn fossil fuels, a fossil fuel is going to be anything that comes from an organic source. We release carbon dioxide into the atmosphere. So when you release carbon dioxide, if you have water around, you're going to have those combine and become carbonic acid. Carbonic acid is going to weather limestone and marble. It's going to eat away at it. So that's that chemical that's going to dissolve the rock minerals. You're going to see this happening again when we talk about caves. You'll see some examples of this and some pictures of this happening. Living organisms is another way that you can chemically change the composition of a rock. So all of these little fluffy looking things on top of this rock, these are called lichens. Now a lichen is an organism that is part of primary succession. Remember, primary succession is what happens after you completely remove all life from an area. So there's nothing there, there's nothing to start with. Lichens are going to form on the surfaces of the rocks and provide the first minerals and things that are needed for life. So all of these little things that look almost kind of fuzzy, these are little patches of just a very thin moss type thing that grow on these rocks. And this is actually a life form. So they're going to grow on these rocks. They're going to produce a weak acid, and that weak acid is going to eat away at the rock. Acid rain. Remember those fossil fuels? Coal, oil, gas. A fossil fuel is anything that comes from a living organism. So things that used to be alive and now are dead. Again, we talked about these a little bit during geologic time. Living things die, they get buried, they get compressed, and they're going to become some type of coal, oil, or gas. Those are going to react chemically with water and form acids. As we're using these things in our factories, in our cars, we're releasing carbon dioxide and various acids into the atmosphere, into our water supply, and that is going to cause things like acid rain. These things are going to cause chemical weathering. Anytime you have an acid going across a rock, it is going to eat away at it. So what is the rate of weathering? When you have more rain, wetter conditions, when it's warmer, you're going to have more chemical weathering. Warmer temperatures mean more rain. More rain mixing with the carbon dioxide that we put off into the atmosphere with all of our fossil fuels means acid rain, means forming carbonic acid that's going to get into be the groundwater. Carbonic acid in groundwater going over rock is going to eat away at it. Acid rain flowing over rock going to eat away at it. When it's colder or drier, you're going to have more physical weathering. So these are going to be arid locations, places that don't see a lot of rain. Typically, these are going to be places where you're going to have lots of the physical weathering. So the frost wedging from the cold temperatures, you do have a little bit of water that freezes and thaws. That's going to give you the frost wedging, frost heaving. You're going to have a lot of weathering by things hitting each other, those kinds of things. So what are some of the effects of chemical weathering? We call this karst topography, and basically it's what happens underneath the surface due to chemical weathering. So remember that chemical weathering eats away at the rock. It basically melts the rock. It's going to dissolve it. Any type of region or area that has a lot of really soft rock is going to have a lot of chemical weathering, and we call that karst topography. Southern Missouri has massive amounts of this. The image over here on the right is the distribution of caves in Missouri, so where they're all found at, and look down here. Southern Missouri has tons and tons of caves. We have really, really soft limestone and dolomite in this area. Because it is such a soft rock, it's easily chemically weathered away. It dissolves very easily in the carbonic acid. So areas that have this karst topography are characterized by things like caves, sinkholes, and what we call disappearing streams. So these are streams that actually run into a cave, and you don't actually see where it goes. You just see it disappear into a hole. These are created by the chemical weathering of limestone. So the acids in the water eat away and dissolve that limestone rock really, really easily. And again, when we talk about caves, you'll see some of this happening. So we've got a very short animation here that you're going to take a look at that's going to show you how a karst formation works and a little bit about the landscape of a karst formation. So you can kind of see how that happens. So go ahead and pause me, watch this short animation here, and then come back. All right, so we're going to take a look specifically at some of the features of karsts. There's not a whole lot to write down for this section. It's just kind of interesting to see the pictures and kind of put a visual with what we're talking about. So sinkholes. The sinkholes that we think of are these massive things. You can actually have smaller sinkholes as well. When I was a paramedic, we actually ran a call because a guy stepped through the street. He was walking down the street, and all of a sudden, on one of his steps, his foot went through the asphalt because there was nothing underneath it. There was a giant sinkhole underneath the asphalt there, and he just stepped into it, stepped through the asphalt because there was nothing to support it. And so we had to get him out of that, and it was interesting because we couldn't get close to it until we figured out how large it was. So they had to place ladders around and find a perimeter and find a safe way to get him out of the hole. These images are from much larger sinkholes, obviously. The one on the right happened on a road. These two cars, unfortunately, they went across a weak section of the road because there was nothing underneath it. You had all this asphalt, but the sinkhole had opened up underneath it, so nothing was supporting it. So when the car drove across, as it drove, it just fell through. And then obviously the second one was not paying close enough attention or was not far enough behind, one of the two, and fell in as well. The one on the left here, you have a neighborhood that had a giant sinkhole open up in it. These houses were pretty lucky to not be affected by it. It stopped before it got to them. However, I can't imagine those are very stable anymore, and those people probably ended up having to leave as well because this is very unstable ground here. Caves themselves are features of karsts. You can have subtle caves like this one down here. You can have the cool caves that open up into the water. This one is an underground cave. You've got an ice cave over here, and then another cave that's kind of hidden away on the lower right here. We're going to be focusing in on caves coming up in a couple of future lessons, so you'll get to learn a lot more about them coming up here soon. And then finally, we have the disappearing streams. These are the streams, again, that flow into some type of opening. Sometimes it's large like this and you can tell what it is. Other times it's just a very subtle opening that you may not even know is an opening, and it just looks like the stream disappears. It's going to go into the cave here, and it will eventually flow out somewhere else, typically on a cliff face or possibly even another cave opening at the other end. This is our last slide for the day. As you finish up here, you will need to go back into Canvas, open up your homework assignment, and work on that web quest. And once you're done with that, get it turned in, and you are done for the day. We'll see you next time.